Hello. Today I will tell you about a new technology for finding patterns in statistical data, which has common features with neural networks, but uses a completely different approach to finding patterns. This technology can be used to solve various problems. I'll show you how to use it for a specific task from start to finish, with detailed explanations. In addition, I will explain how to use this technology to solve other problems. To demonstrate this example, I will use a program that can be downloaded from the link in the article. To understand how this technology works, most of the code will be opened. So, let's get started. Let's solve the problem of finding patterns in statistical data in exchange trading. This example was chosen because it is easy to test. First, we formulate the problem itself. It will sound like this. Find such combinations of parameters that events will develop in the desired direction with a probability of 80%. Consider the buy search problem. First, let's look at the result of solving this problem. Let's run the found patterns in the tester for the period from January 1, 2008 to the beginning of March 2024. We see a graph created on the basis of algorithms that were found by the program for finding patterns in statistical data. As we can see, the solution to the problem was found with the given probability. Let's look at how to find such patterns. This task consists of 3 stages. The first stage is data collection. The second stage is data analysis and processing, identifying patterns on the basis of which algorithms are developed. The third stage is the application of ready-made algorithms for solving specific problems. Let's first look at the result that should be obtained as a result of data collection. You see a table consisting of zeros and ones. Let's look at some examples of what it is. First, let's understand what each line means. For a better understanding, let's imagine that we are solving an image recognition problem with numbers. We have a 28x28 pixel image, which is 784 pixels in total. The image must be without halftones, where the light pixel is 0 and the dark pixel is 1. If we connect all the lines of the image sequentially, we get a single line. The first line of the image is highlighted in red, the second line is highlighted in green, the third line is highlighted in yellow, and so on. The line obtained after processing the drawing will become one of the rows in our table. Thus, when solving any problem for each object, you need to collect information in binary form, using the same parameters. The parameter values in different objects may differ, but their order must be the same. In the case of digit recognition, the object is a drawing, and the parameter is a single pixel. If we are trying to determine whether it is a man or a woman, then the object will be a person, and we can use, for example, the shape of the eyes as a parameter. Now let's move on to our task. Let's find out what an object and parameter are. First, let's look at the object. In the simplest case, each bar can be an object. However, when collecting information in each bar, and when using algorithms, we may encounter a problem of batching, which can lead to very large drawdowns. Therefore, it is better not to use this approach. To avoid such problems, it is better to distribute objects over time. How does it work? You need to set certain conditions that will be met after a certain period of time. For the demonstration, we chose the simplest condition. Its essence is that 2 moving averages must intersect. The fast average crosses the slow one from the bottom up. Let's see how this works in practice. We can see that if this condition is met, a vertical line is drawn. Thus, the object in which we will collect the conditions is found. Let's look at how we collect parameters. To do this, we will use 2 types of technical analysis, candle and indicator. Let's take a look at how data for candle analysis is collected in the code. First of all, I want to say that the code will be discussed in detail in the video that will be attached with the program for downloading. In this video, we will show only those parts of the code that are necessary for a general understanding of this technology. Let's look at candle analysis. We see a null parameter, but what does it mean? If the closing price of the first bar is greater than or equal to the opening price, then the parameter is equal to 1. Otherwise, it is 0. The same condition applies for the second bar and so on. Let's look at the 7th parameter. Here we compare the closing prices of the first and second bars. As a result, we get 133 parameters for analyzing candlesticks. The remaining 123 parameters are obtained using indicator analysis. Knowing the code, it is easy to understand how these parameters are formed. Then we need to collect information about the conditions at this point and determine the levels that we can use to understand how this object worked, positively or negatively. To do this, when the item is located, we will collect parameters, set a virtual bid, and set its stop loss and take profit levels. On the graph, you can see a vertical yellow line that shows the location of the object. The blue horizontal line indicates the price of the virtual bet. The red horizontal line is the stop-loss level. The white horizontal line represents the take-profit level. Do you see that the price has exceeded the white line? This means that the item has shown positive dynamics, as we are looking for buy bids with an 80% success rate. In another case, the price has fallen below the red line, which means that the asset has suffered losses. So we collected data to create algorithms. Let's take another look at the resulting table. You see the first column track. It also contains zeros and ones. This means that for each row with parameters, if the object worked well, then the cell will contain 1, and if it is bad, 0. The search for algorithms is always carried out in the direction of unity, that is, positive objects. Now let's collect all the objects that were created between January 1, 2008, and the beginning of March 2024. After collecting all the necessary information, we will move on to data analysis. The log shows the number of objects that showed positive and negative results. In this case, we have 1,697 objects, 691 of them showed positive results, and 1,006 negative. All data that we have received is saved to a file. Let's create a separate folder for them and put this file there. Now let's open the program for getting algorithms and download this file. As we can see, after downloading, information about the file appears. A total of 256 parameters are available. This version of the program can only handle up to 256 such parameters. The total number of objects is 1,697, of which 691 showed a positive result, and 1,006 negative. You can view the received data. This completes the first stage of the task data collection. Now we move on to the second stage, data processing and finding patterns, hereinafter referred to as algorithms. To set up algorithm search, go to the Algorithm Search tab. Here you will find the parameters that you need to set to search for the necessary algorithms. First, let's discuss the settings. Suppose we set the following conditions. The minimum loss percentage is 0% and the maximum loss percentage is 20%. This means that we need to find algorithms that will show results in statistical data with a loss rate from 0% to 20%. In other words, the win should be between 80% and 100%. We will place a minimum number of bets equal to 1%. Then we will start searching for algorithms with these parameters. When searching for algorithms, the button will be displayed in red. Now let's find out what 1% of the minimum number of bets means. In the field, you can see that 1% is equal to 6. To understand the value of this number, go to the Download tab. We can see that the number of positive bids is 691. 1% of this number is 6 bets. In other words, we use this setting to set the minimum number of positive bids that each algorithm should cover. In our case, each algorithm must cover at least 6 positive bids. At the same time, the number of positive bids from the total number of bids must be at least 80%. As we can see, the table with statistical data containing 256 columns and 1,697 rows was processed in 1 minute and 25 seconds. The result of the work was a package that includes 68 algorithms. These algorithms were written in 2 files, one in binary format, the other in text format. A binary file is necessary for the system to work, and a text file is necessary for understanding and analyzing algorithms. The algorithms that we see on the screen were read from a binary file. The text file contains additional information, so let's run it and examine the data that is presented there. First, let's look at the first algorithm and understand how it works. This algorithm uses 8 parameters. In the first line we see the parameter number, and in the next line its value. Let's look at how this algorithm works. We can see that the first parameter of the algorithm is 19, and its value is 0. The second parameter is 39, the value is also 0, and so on. The last parameter is 207, and its value is 1. Then we see 2 objects with full parameters. The algorithm works as follows. The value of each parameter from the algorithm is alternately compared with the corresponding parameter of the object. If all the values of the algorithm parameters match the corresponding values of the object parameters, the algorithm will work. The second object has all the parameters matched, so the algorithm will work. The first object has different parameters, so the algorithm won't work. Next, let's look at what other data is present in the text file. The first line contains the number of draft algorithms equal to 73. In neural networks, there is such a thing as overfitting. This concept cannot be better suited here. What does it mean? If we run the entire package of rough algorithms, the cumulative result will not be what we expect. In this case, the probability will be less than 80%. Therefore, the program generates a package of optimized algorithms by default. When solving this problem, it consists of 68 algorithms, which gives a probability of 80%. There are different ways to use a draft package. All the ways to use it will be described in other videos in the article. Then there is the percentage of coverage of winnings. What it is, we will consider a little later. The next lines are the number of positive objects and the number of negative objects, then the probability. These values show how this algorithm will work in the statistical data under study. The second stage is solved. We processed the data and got the algorithms. Let's move on to the third stage of the problem, using the obtained algorithms. First, you need to transfer the created algorithms to the tester files folder on the MetaTrader platform. Let's look at the operation of one algorithm. As an example, let's take an algorithm with ID 13. As we can see, this algorithm has 9 positive inputs, 1 negative input, 90% success rate, 56 parameters in the algorithm. This algorithm clearly shows what the probability of success is for a particular algorithm. There are 10 inputs in total, including 9 positive ones. 9 out of 10 give 90%. Let's check whether the patterns in this algorithm are correctly identified. In the program for working with algorithms, you can run a single algorithm. To do this, we pass algorithm number 13 to the function that checks object parameters and algorithm parameters. Let's run the program for the period from the 1st of January 2008 to the beginning of March 2024. We can see that the algorithm worked correctly. Out of 10 inputs, there were 9 positive and 1 negative. The success rate was 90%. Now let's run the algorithm package in the same time frame. As you can see, it should work out and show a full probability of 80%. The coverage of winnings is 21.99%. To do this, we need to change the values that are sent to the function. We can see that the problem was solved correctly. The probability was 80%. Now let's find out what the percentage of coverage of winnings means. 21.99. The report shows that the number of profitable trades is 152. When collecting data for algorithm search, the total number of objects was 1,697. Of these, the number of positive inputs is 691. Thus, 152 profitable trades account for 21% of the total number of positive entries, which is 691. Task: find such combinations of parameters that events will develop in the desired direction with a probability of 80%. Solved. Now let's take a closer look at the algorithms and how to analyze them. The algorithm consists of various parameters. For example, consider a null algorithm that contains certain parameters. To better understand what each of these parameters means, let's take a look at the code. Exactly the parameters that are involved in this algorithm were cut out of the code. Let's analyze the operation of several parameters. The 19th parameter must be 0. This means that it will trigger if the closing price of the 5th bar is greater than the closing price of the 3rd bar. The 39th parameter must also be set to 0. It will work if the high price of the 4th bar is higher than the high price of the 3rd bar. So by studying the code and analyzing the parameters, we can understand how each algorithm works. Using a complete set of algorithms, you can determine the probability of success for each object. The graph shows the probability of success for each individual object. More detailed information is shown in the following videos. This technology can be described as input parameters are sent to the input. Each parameter is associated with specific algorithms that use it. At the output, we get the probability. Let's take a look at how you can solve another task. Let's say we need to learn how to determine whether this is a man or a woman. This can be done in a similar way. We have a table that contains different characteristics for each object. Accordingly, to solve this problem, we need to create two sets of algorithms. The first set will contain algorithms for determining men. In the track column, we will put a unit for all objects for men and find algorithms for recognizing them. Then, in the track column, we will put one for all objects that relate to women and find algorithms for recognizing women. When we receive data for determining gender, we will check it with two sets of algorithms and choose the one that shows the highest probability. The capabilities of this technology are shown in the following videos in the article.